calculator basics. Alright, we're going to go and start with the basics. Here's a TI-84 Plus Silver Edition calculator, but again, as long as you have any form of a TI-84, whether it's Plus, Silver Edition, or the new color models, they should all look the same. And so now we're going to start, we're going to go ahead and turn it on. I'm going to clear that introductory message. And the first thing I want to do is go to mode. So we want to make sure that the entire left side is completely highlighted when we go to mode. In particular, I want to make sure that I'm in radian mode all the time. And I'm actually going to go ahead and click all the way down because I also want to be in math print. So if you have an updated version of an 84, then you should automatically be under math print. But if you don't have an updated 84 calculator, then the bottom of your screen will only say set clock. So there won't even be this option to scroll down to the second page and see math print. If that's the case for you, I'm going to ask you to come and see me right away on the first day of school so that I can update your calculator so that math print is an option. Alright, so now, again, the whole left column needs to be lit up, needs to be the highlighted column, and then I'm going to go ahead and get out of this menu by going to second mode, which is quit, to get back to the home screen. And the first thing I want to focus on is how to reset your calculator, because so many times during a test I have students say, my calculator got stuck, it's not working, it's not graphing, and the number one thing I'm going to recommend is reset your calculator, because I can't help you. Just like I can't help you on the AP exam, you need to know how to work your calculator, and the best thing to do is to reset it. So this is something that you definitely need to have memorized, resetting. And to do this, you're going to go to second, and then you're going to choose plus for memory, MEM, and then you're going to go to 7 for reset. So you can go all the way down, but I use the number shortcut. So 7, I want to clear all RAM, so I'm going to hit 1, and then reset, I'm going to press 2. So notice I have this screen that says RAM cleared, so it went ahead and cleared all the different settings that I may have changed, or if I let my friend borrow it, my friend may have changed, and gets me back to as if I took it out of the box. And so now I'm going to go ahead and go back to the home screen. So if you need to rewind, or if you want to just go ahead and try to memorize it, it's second plus, and then the numbers are 712. You should have that memorized because it is that important. So now the next thing we're going to go ahead and focus on is graphing. So to graph, I'm going to go ahead and go to y equals. So of course we can enter as many functions as we'd like here. One of the things I want to point out is that these plots should not be highlighted. So if I go up one, I can see this flashing above plot 1. If I hit enter, plot 1 is going to be turned on. So I have a lot of students have weird dots all over their screen. It's because they have a plot turned on. So if that's the case, you always want to make sure and highlight over it and hit enter so that it's no longer highlighted. Alright, so now y1. The first function that I'm going to enter is a rational function. So I have x squared plus 3 over x squared minus x minus 1. So the benefit of having math print is that right now entering this rational function, if we didn't have math print, we'd have to enter this in with a set of parentheses around the numerator and a set of parentheses around the denominator. But with math print, I can go ahead and, as long as I'm under y1, I can choose alpha, so the green button, in my calculator it's green, and then I'm going to choose y equals. So in other words, I'm going to menu F1. And the first option is n over d, which means numerator over denominator, and I'm going to hit enter. And now the fraction bar will show up, and I can go ahead and enter x squared plus 3. So I'm going to enter x, use my caret button to get into the exponent, so x squared. Another common mistake of being in math print is that when you go up to the exponent, forgetting to come back down to the regular line to enter my plus 3. So I want to make sure that my plus 3 is on the same line as my x, and my 2 is up in the exponent of x. Then I can move down and do the same thing with x squared, and then minus x minus 1. Or I could have used the squared button for x, it doesn't matter. And then I'm going to go ahead and hit graph. So because my calculator was reset, I am in the standard viewing window, which is the next thing I want to discuss. The standard viewing window, if I choose zoom, Number 6, and this is another shortcut you want to remember, is zoom 6. The standard viewing window, so if I choose it again, nothing about my graph is really going to change. It's just going to redraw for me. The standard viewing window goes from -10 on the x-axis to +10 on the x-axis and -10 to +10 on the y-axis. Now this is always a good starting location, but if you didn't see a comprehensive graph, which means the entire thing, as in any potential x-intercepts, any y-intercepts, then you're going to want to manually change the window. So that's when we would go to Window, and change our x min and x max, so the smallest x to the biggest x, our x scale. The scale is the little tick marks, so the tick marks are going by 1, and then -10 to 10 on the y axis with a y scale of 1. So if I go back to the graph, each of these little tick marks is 1. So I'm actually going to change those tick marks right now to be every 5, just for the x scale, just so we can see what would happen there. So we want to use this option when we have sort of a cluttered graph, and what happens is the x-axis or the y-axis looks like a solid, dark, thick line. That usually means we need to change our scale. So here that was sort of unnecessary because it looked fine, but just to show you now how there's only one tick mark halfway, because if this is 10, then this tick mark goes every 5. Now I'm going to go ahead and move on to graphing y equals sine squared x on the interval from -2 pi to 2 pi. So this right here is a restricted domain. These are x values. So it's like saying for x values on -2 pi to 2 pi. So this is actually telling me my x min value and my x maximum value. So I'm going to need to change that probably prior to even graphing the function. And now I wanted to go over this function in particular because this one ends up being one where students get stuck and say, it's not working, it's not working. Well, it's typically not working because students want to make the function in their calculator look exactly how it looks on their paper. So sine squared x, if I were to go ahead and go to y equals here and clear this out and just go straight to sine, and then somehow want to enter in a squared right here somehow, or enter in x and then hit squared like this. Now the squared is only associated with this x. So it's not in the correct position. So here's what I need to do. I have to recognize, and this is just a really important point in general, is that sine squared x is really the quantity sine x all being squared. So I need to start out with a set of parentheses. I need to start with parentheses and then put sine x. So now that parentheses close this one. So now I need one more. And then I'm going to take that whole quantity and square it. So this is how I'm going to need to enter sine squared x. So it is really sine x in parentheses squared. And any time I see a little exponent with any trig function in this location, I want to rewrite it as that trig function in parentheses raised to whatever exponent was right there. So now before I even hit graph, I'm going to go to Window, because as I said, this is a restricted domain. We're talking about x values from -2 pi to 2 pi. So for x min, I'm going to enter negative, not minus. There's another common pitfall. If students enter negative and minus as though they're the same thing. So right now this is -2 pi. So I actually want to enter in the pi option. So I have to go to second and the division. Oh, whoops, I missed it. Sorry. Second and the caret button. So there's the little pi symbol. And then my x max, I just want to be +2 pi. So I'm going to go to that same location. And then notice once you hit enter, what it does is give you a decimal representation instead. And I'm going to go ahead and change my x scale back to 1 for now. And I'm going to leave my y min, y max, and y scale to be -10, 10, and 1. And then I'm going to hit graph. So now here I have my graph of sine squared x from -2 pi, that's way over here, to 2 pi, and my y scale is from -10 to 10. So this particular graph, I would say, is not in the best possible viewing window because I can probably see a little better what's going on if I were to change my y min and y max. So I'm going to go ahead and change it so I can kind of see that I should maybe stay within -3 to 3 here. So just a little warning from me. Although it's not incorrect and there's nothing wrong with it, I don't really like choosing the option zoom fit, which is what a lot of students want to do. So under the zoom menu, there's some different options: zoom box, zoom in, zoom out. And a lot of times students want to go to this option of zoom fit. I don't really like this particular option. If you're comfortable with it already and you know how to manipulate it, that's fine. But I would prefer going to window and manually changing your scale. So I'm going to go from -3 to 3. Keep my y scale of 1. My tick mark's at 1 on the y-axis. So now this is a better graph for sine squared x. I can see a lot more of what's happening. I can see the curve a little bit better if I were asked to sketch this graph. So this is a much better graph of sine squared x on -2 pi to 2 pi. And the final function we're going to take a look at, we're going to try to graph y equals the cube root of x squared. So I'm going to go ahead and go back to y equals now, clear out the graph that I have. And there's actually two different ways I can graph this function. The first way I'm going to focus on is understanding how to rewrite this cube root as a fractional exponent. So here, the cube root of x squared, well, what's happening is whatever's underneath the square root, which is, or I'm sorry, the cube root, which is x squared, gets taken to the power of 1 over 3. So the cube root becomes the fractional exponent 1 over 3. And my properties of exponents say I multiply these two. So this is really x to the 2 divided by 3. So that's one way I can enter in this function. So I can write x raised to the power of 2 divided by 3. So I can write my fractional exponent up in the exponent of the variable x here, and I can go ahead and graph this function. So one of the things I want you to notice is that the viewing window did not change from what we had it saved as for sine squared x. So what I want to do right now is go ahead and go to zoom 6 for standard. Again, one of the things you want to memorize, zoom 6. Because in general, I always want to start at the standard viewing window, of course, unless I'm given a restricted domain in the first place, but I always want to start at -10 to 10, -10 to 10, just to get an idea and then start changing the window from there. So here, this is the graph of x to the 2/3, but just to review how to enter it the other way, because we have math print on that updated operating system, another option is to go to Actually, we don't need to choose that. We can go to Math, and option 5, you'll see has a little x and a little radical symbol. So if I choose 5, now I have a way to make it look exactly as the function was given. So I can enter 3 and then x squared. And then I can go ahead and hit graph. And hopefully you notice that nothing looks different at all, because it's like I just graphed the same exact function twice. So it didn't reappear. It was the exact same function because those are two alternate ways to draw the graph. Now, because I have two functions in, now is a good time to show how to turn a particular function off without clearing it. So sometimes we only want to focus on one function. So what I'm going to do right now is I'm going to highlight the equal sign, and I'm going to hit enter. And what that will do is unhighlight the equal sign. So what that's saying is, for now, just go ahead and graph y2. So now if I choose graph, now only y2 is being graphed. But if I ever need to use y1 again, I can just turn it back on instead of having to re-enter it, especially if it's an ugly type of function that I wouldn't want to enter over and over and over again. The next thing I want to cover is using your calculator to evaluate functions or find function values. So we're going to stick with the same function, y equals the cube root of x squared, because I already have it entered. So I'm leaving x to the 2/3 in my calculator, making sure the equal sign is highlighted again. And I'm being asked to evaluate this function at two different x values. So find y of 8 and find y of 3. Now, y of 8 is a value that we can find by hand. We can compute y of 8 exactly if I go ahead and substitute 8 into this x. So in other words, I can go ahead and do the cube root of 8 squared. Well, 8 squared is 64. So the cube root of 64 is 4. So this was something I could do by hand, but we're going to pretend that I can't, or if I'm asked to use my calculator to do this. And we're going to do this in 3 separate ways. So again, I want to make sure y1 is highlighted and that my given function is entered. Now, the first way we're going to do this, I'm going to go ahead and go to second quit, and I want to get to my home screen. And I want to go to vars. And then I want to move to the right because I want to go to yvar. So I'm going to hit the right button. And I want to hit 1 for function, or just go ahead and hit enter. And the function that I stored the cube root of x squared under, I stored it under y1. So I'm going to go ahead and hit enter. So I want y1 of, so write the parentheses, of 8. So y1 of 8, if I go ahead and press enter, it's going to evaluate my function for me. So this is one of the ways I can evaluate a function as long as I have y1 stored as a particular function, and then I go to vars, again, go over to yvars, and then 1 for function to recall the function that I need, and then substitute in my value in parentheses. So make it look exactly like this notation. Now for a second way to get that exact same value out, I can go ahead and go to graph. So we already know what the graph of this looks like sort of this little V with curve to it. And I can go to the trace option. So I can go ahead and hit trace, which puts a little cursor on my function. And I can go ahead and move that cursor around, but what's going to happen is that the cursor is going to trace the graph, but it's going to go to arbitrary x values with their corresponding y values as I continue to go to the right or the left. So if you look at those x values, they're just sort of weird arbitrary values as I move to the left and the right. But what I can do is I can go ahead and choose any x value I want. So the x value I want to plug in is 8. So if I hit 8, notice on the bottom left I have x equals 8. If I press enter, I will automatically move that cursor to the exact coordinate point with the x value of 8, and reading the y value will tell me that number 4, which again we could have found by hand. But this one we could not find exactly by hand, so let's go ahead and try this one. I'm going to hit trace again, let my x value be 3 this time, and hit enter. So now I can see that the corresponding y value is 2.080. So always, this is another good time to talk about some rules in calculus. I'm always going to round or truncate, truncate means cut off, to the thousandths place. So 2.080. So rounding and truncating will leave my thousandths place at a 0. And even though that digit is 0, I always need 3 places past the decimal, even if what's in that thousandths place is the digit 0. So 2 and 80 thousandths is going to be my rounded or truncated answer to what is y of 3. So it's 2 ways to do it. The third way we can do it is to go to table. Now before I go to table, I want to go to table set. So I'm going to go to second and then window for table set. And you might have some different stuff going on here. Generally, what you're going to have is a 0. So I'm just going to put a 0 there. And delta table is going to be 1. So we'll go ahead and leave it as that default. And you might have independent under auto. This might be highlighted. But what I need you to do is make it so that ask is highlighted for the independent variable. And dependent is going to stay auto. So you're going to highlight that, you're going to go ahead and hit enter, and then you're going to go to second graph for table. And right now there might be values here, it might be blank, but what we're going to do is we're going to put specific x values here on the left. So what x values? 8 and 3. So if I enter 8, notice the corresponding y1 value is 4, and then if I plug in 3, the corresponding y1 value is 2.0801. And that's what we got using the graphical method and using trace. So there's 3 different ways to evaluate a function on your calculator. Alright, this next part is one I really need you to pay attention to. If I have a question that says solve e to the x over 4 equals negative x squared minus 2x plus 3. I actually have 2 different ways on my graphing calculator that I can solve this problem. So method 1 is the intersection method. Method 1 is by intersection. So in other words, this function on the left of the equal sign, e to the x over 4, that's one function. So I'm going to call that function y1. And on the right-hand side, that's my function y2. So when I'm asked to solve this equation, remember what we're solving for. We're solving for x values. So what x values make this equation true? Well, if I think of this as two separate functions, it's like asking, where do these two things meet, or where do they intersect? So what I'm going to go ahead and do is enter each function in separately. So e to the x over 4 is y1. So now we can come over to our calculator, and we can go ahead and enter, whoops. So I want to go to second, e to the x, so that's right over here where natural log is. So remember the e button was over here, and I could have used that, but this one's set up so that I can go ahead and enter variables in the exponent. So e to the x over 4 is one function that I'm going to hit enter. And then negative x squared, so here's that whole difference between negative and minus. So negative x squared, and then I'm going to get out of the exponent, minus 2x, and then plus 3. So this one is a negative and this one is a minus. And if you do them incorrectly, you will not get the correct graph. But we should already know what each of these looks like. So e to the x over 4 is going to be an exponential growth function. And then negative x squared minus 2x plus 3 is going to be a parabola that faces downward because the leading coefficient is negative. So I'm going to go ahead and graph this. I'm going to go ahead and go to Zoom Standard already. I'm going to hit Zoom 6 just in case my window was not the standard viewing window. So there's my exponential growth function, and there's my downward facing parabola. And so what I'm interested in is these 2 points of intersection. So I can clearly see on the graph, first of all, I see a comprehensive graph. I see my exponential, I see my quadratic graph, and I can see very clearly where those 2 points meet. So now I can go ahead and go to second, trace, and I can choose 5 for intersect. I want to know where they intersect. And now what the calculator is doing is it's telling me a few things and asking me a few things. So let's go with what it's telling me. It's telling me I'm on the curve y1. I'm on e to the x over 4. That's where my little flashing x is. And from here, I want to move only left and right because moving up and down will switch me between functions. I don't want to do that. I want to stay on y1 and I want to move to the left. So I want to move close to that point of intersection, hovering right on it. And right now it's asking me, all right, are you on the first curve near that point of intersection that we're looking for together? And so yes, I'm on the first curve and I'm near that point, so now I'm going to hit enter. Now I'm being told, okay, I switched you to the second curve, and tell me if that's the second curve you're talking about, because we may have entered a lot of functions, a y3, a y4, etc. Then we would use the up and down arrows to get to the right function. But there's only 2. It switched you automatically. Are you still near that point of intersection on the second curve? So we're going to hit enter. And then under guess, we hit enter again. Always hit enter on guess. And now we found our point of intersection. And here we're only interested in the x value of the point of intersection because when I'm solving an equation, I'm solving for x. What x value or values will make this thing true? So now I'm going to go ahead and copy down that x value. Again, I always go to the thousandths place. And I'm going to have negative 2.874. If I round or truncate, I get the same answer. So that's one x value. And now I have to repeat the process over here with this other point of intersection. So I have to go to second, calc, 5 for intersect, and then move myself on over near the second point of intersection. And am I on the first curve? Yes, I am. Am I on the second curve? Yes, because there's only 2 curves. And then I hit enter. Always hit enter on guess. And now here's my second point of intersection. I'm only concerned with the x value again. So I'm going to go ahead and copy down 0.677. The other acceptable answer would have been 0.678 if I were to round to the thousandths place. So it doesn't matter which one you write, but it has to be correct out to the thousandths place. So now this was, again, the intersection method. A lot of people memorize it as go to the point of intersection and hit enter, enter, enter. But we're going to end up getting to the case where I enter more than two functions here. So I might have a y3 and a y4, and I have to correctly identify which functions I want to find their points of intersection for. So I don't want you to memorize it as just a series of steps that always works the same every time. You really have to think about exactly what you're doing and what the calculator is asking you to do. The second method I want to cover, method 2, is the zeros method. So I'll put a little line through my z to indicate it's a z because it looks a lot like my 2. So the zeros method is one in which I take one function and I subtract it to the other side of the equal sign so that the entire equation is set equal to 0. So in other words, I already have e to the x over 4 on the left. So I'm going to rewrite that, e to the x over 4. And then if this is negative x squared, if I add it to the other side, it's going to be plus x squared. And then I'm going to have plus 2x, and then I'm going to have minus 3 equals 0. So what I just did is I subtracted y2 to the other side. So in other words, what I can do now is I can go ahead and enter this entire function here as a y1 function and find where this y1 function crosses the x-axis. So 0, this is really the x-axis. So I can find the zeros of this function. So here's what I'm going to do. I'm not even going to delete these functions. I'm going to go ahead and unhighlight them. And now under y3, I'm going to go ahead and enter this as a new function. So I'm going to go ahead and call this function y3. Looks like a b. Sorry. So I'm going to go ahead and call this function y3, and I'm going to go ahead and enter it. So second, and then I'm going to have x divided by 4, and then we added x squared, we added 2x, and we subtracted 3. Alright, so now what I'm going to do is I'm going to graph this one function. So the other two will not appear because I turned them off. And now what I'm interested in finding is not their points of intersection, but the zeros, or if you want to think of it as the points of intersection with the x-axis. So I'm looking for that value right there and this value right here. So to find zeros, I have to go to second trace for calculate, and this time I choose 2 for 0. So I'm going to go ahead and choose 2. And now this process tends to confuse students. Because again, they're trying to memorize it as a sequence of steps. But I really have to look at what the problem is asking me to do. So right now, the calculator is telling me I'm on the function y3. And it's asking me, left bound, are you on the left side of the 0 that you're trying to find? I'm going to go ahead and try to find this 0 right here first. So I'm going to move to the left of that 0. So right about there, I'm on the 0. I want to be to the left of it. So I want to be on this side. I don't want to think about it as above or below. I want to think about it as on the left side of where I cross the x-axis. So I'm going to move one time over. So now I'm clearly on the left side of this 0, and now I'm going to choose enter. Well, now it's saying, are you on the right side? So I'm going to have to use my right arrow. I don't want to go up or down unless I want to switch between functions. And in this case, I don't want to switch between functions. So I moved a couple places to the right. So now I'm clearly on the right side of this 0. Again, I don't want to think about above or below. I want to think about on the right-hand side. I happen to be below, but I'm to the right. And now I hit enter. On guess, we always hit enter. And if you notice, we get the exact same answer we got using the intersection method. So I get negative 2.874 if I were to round or truncate. And then we would do the same process over here with this other 0. So we'll do that one a little more quickly. Second calc, we're going to choose 2 for 0. And now it's asking me, are you on the left side of the other 0 you want to find? Well, right now, you might be thinking, well, yeah, I'm on the left side, right? Because here's the 0. It's way over here on the left. But that's too far left. I want to be still kind of close to it, but to the left of it. So I'm going to go a few more places. All right, so there's my 0. I want to be on the left side of it, but still kind of close to it. So again, not above or below, on the left side. So then I'm going to go ahead and hit enter. Now I want to be on the right side, so hit the right button a couple times. Now I'm clearly on the right hand side. I'm on the graph, but on the right side of the 0. And then I hit enter, enter on guess, and that gets me my 0.677 or 0.678 if I were to round. So this is another option for solving an equation. So the intersection method or the zeros method. And there's one more thing that I want to show you. If you have to use the zeros method, so notice what we did is we took y2 and we subtracted it to the other side. So one final way you can think about the zeros method is I'm leaving y1 on the left-hand side, right? E to the x over 4, it stayed on the left. And y2 is this whole entire thing on the right. And what I can think about doing is just subtracting all of y2 to the other side and setting y1 minus y2 equal to 0. So this is actually a little shortcut that I like to teach that we will use very frequently later, is instead of having to retype this whole thing like we did right now as y3, another clever thing I could have done is instead enter y1 minus y2. So y1 is already e to the x over 4. So what we're going to do is go to vars, go over to yvars, we've went here already, 1 for function, and we're going to choose y1 as the first function, and then we're going to subtract y2 as the second function. So vars, yvars, enter, go down 1 or choose the number 2 and hit enter. So now y3 is the function y1 minus y2, which is exactly what this entire thing was right here. So I wouldn't have had to re-enter it over and over again. I would have just had to recall y1 minus y2. That is an option. And notice if I were to hit graph, it's going to be that same shape that I had when I entered in y3 with those two same exact zeros. So that in particular is a shortcut I wanted to take the time to show because we will be using that a little later on this year. Alright, and the last big thing that I want to show that's very important is how to store the values that you find. So we previously found points of intersection, those x values. We found the zeros, those x values. So there are going to be times when I need to store that information in my calculator. So I'm going to go ahead and go back to y equals. I'm going to turn these two first functions back on and turn the third one off. And I'm going to go ahead and find a point of intersection again. I already know the values. So I'm going to go ahead and go to second calc. I'm going to go to 5 for intersect. And I'll go ahead and find this right-hand point of intersection again. So this is the one where I can hit enter. Because I'm on the second curve, there's only 2 curves. Enter, enter. So here's my point of intersection, 0.677. So we wrote that down, and you should always write it down as soon as you find it. But if you need to store it, if you need to store that number in your calculator, here's what you need to do. When you have intersections showing on your calculator, so when you have the screen that I currently have, from this screen, you need to immediately close out and go to second quit. And that'll take you to your home screen. So your calculator is currently, it's holding on to that number in its memory. And what you want to do is, right now, on this home screen, you're going to automatically press STO, the button above on. And what that's doing is it's storing the last answer. So the last answer is going to be stored to whatever letter you choose right now. Don't pick X. So we're going to go ahead and choose alpha, and I'm going to pick the letter A. So A is right there, right above math. So I'm choosing to store the previous answer, the X value of the point of intersection. It's always going to save the X value by default. So answer is going to go to the letter A. So I'm going to go ahead and hit enter. And it's confirming that 0.677 and so on. So I didn't just save the first 3 digits past the decimal. I saved the entire exact answer to the letter A. So in other words, if I want to end up using it later, I don't have to enter all these numbers, which in fact I can't answer all those infinitely many numbers if this number is irrational and goes on forever. I can instead go to alpha A and hit enter. And now I can perform operations with that number A. So let's say I want to multiply A by 3. I don't know why we want to do that, but let's just say we did. So now I can do 3 times that number a. So your calculator is going to hold on to that number until you assign something over it. So storing a saved value, so it was holding on to that, but only for a short time, is something you need to know how to do. So it would have worked the same way as when we found a 0. As soon as you find the 0, you go to second quit, and you go to the home screen, and you immediately press store. So you don't want to press store when you're in here under graph. You want to go to second quit, and you have to be on the home screen for it to work. All right, and the final couple tips I want to share are, again, a reminder that there is a difference between the negative symbol and the minus sign, so make sure that you always double check that if you get an error. I want you to very carefully understand the idea of this trace option. So when a lot of times students want to find this point of intersection, they think, oh, I'll just press trace, and there you go, I'm right on top of that point of intersection, so here's the answer, 0.638. That's not good enough. That is not the correct answer. You will not get any credit for that answer. There's a very specific answer, and it has to be one of these two options, 0.67 or 0.68 only. So the trace button, remember, that was only good for if you already know the x value and you want to find the y value. So if I wanted to find just what happens at x equals 5, that's where trace comes in handy, but only then. So I cannot use trace to find zeros or points of intersection. And then another common mistake is thinking that your calculator is perfect. Your calculator is definitely a tool that was programmed by a human being, so it is not a perfect tool. It doesn't show us things like holes in the graph for rational functions when there are holes. Your graphing calculator is pixelated. That's why these don't look like smooth curves. So sometimes the results are a little bit deceiving. So it's really important that you actually understand mathematically what is happening and how you are using your calculator as a tool for the knowledge that you are applying versus using it as a crutch in replacement of not actually understanding what you're doing.